Hello, I'm Amrita Chowdhury. By now, you must have read my son Shoumik's piece about his journey as a student and researcher in quantum computing. We will be speaking in the next session of Talking About My Generation on science and technology and its role in society. I have been closely involved with tech, starting out in breakthrough innovation in Silicon Valley at the start of my career, and as an entrepreneur now in the deep tech space in India. Though I did veer for quite a long time in the middle, into strategy consulting and into heading non-tech businesses. As we look upon Shoumik's journey as an undergrad at Yale, my husband Sumit and I cannot help but look back upon our own experiences as students at IIT Kanpur decades back. We are vicariously enjoying his rich journey. At IIT, in our days at least, we mostly studied and solved problem sets. There was very limited learning by doing through research. Though IITs did have a requirement of taking a set of humanities courses, and I did make the most of it by taking classes in art history and sociology and others, it still doesn't compare with the depth and breadth of STEM and liberal arts education and courses on offer at Yale. The teaching methods are very different too. They encourage students to think differently and to interconnect ideas. Instead of peer competition, they collaborate. All of this makes us feel like going back to college all over again. But getting back to our topic for today. Today, science and technology are being increasingly called upon to deliver creative solutions that impact humanity, solve critical challenges, and lead transformation of human lives and condition. When looking at science and technology, there are 4 important points to consider. First, how do companies and countries take long bets on certain technologies and how that decision can have a lasting impact on those industries? When I graduated from Berkeley and started working in Silicon Valley, the semiconductor industry was just rebounding from the recession of the previous decade, when low-cost Japanese DRAMs had flooded the market. As personal computing and high-tech personal electronics saw a sharp increase in demand, Japan got its competitive edge due to the earlier investments that it had made in chip manufacturing. Consequently, in the 1990s, Silicon Valley firms, as well as the US government, gave deep impetus, investment, and incentives to manufacture the new integrated circuit chips in newly opened fabs across different states, and to retain intellectual property protection within the United States. I recall collaborating with people in different fabs in Oregon, Washington, Texas, Arizona, and other states. I recall the rhetoric that the US semiconductor industry had to revive and to thrive again. I recall the intense competition and the secrecy amid firms to become the first ones to develop scientific products, specific products, and ring-fence it with patents. I recall the buzz and the excitement. Parties, food, Friday concerts, Napa Valley trips. Things that we young engineers were indulged with. Even today, the US manufacturers have more than 50% of the global market share of the integrated circuit chips manufacturing area. And more than 50% of those ICs manufactured by US headquartered companies come from fab units located on US soil. This is a very different narrative from the low-cost offshore manufacturing approach that we see in other industries. Today, as I view from a distance through Shoumik's eyes, the intense competition between companies and countries to invest in quantum computing and the hot money chasing the field, I can see a similar pattern. Second, technology has a long gestation period before it matures and becomes transformative. Whereas businesses rely upon application-ready technologies to grow now. I can see a difference in my own approach. I had worked on an idea that had emerged out of a university lab, and my company, Applied Materials, had decided to explore commercializing it. As a young engineer, I struggled with multiple dead ends for more than a year, till things worked out and eventually led to a production-ready product and process. As a tech entrepreneur in India, I have to face clients. We have business goals and deadlines. Sometimes those deadlines are for next week, sometimes for next month. So despite my earlier experiences, I'm impatient. I need my tech team to deliver results tomorrow. So how do we consider return on investment in science and technology? How do we as individuals develop the resilience needed to stay the course in scientific exploration or product development? Third, the true power of innovation in solving challenging problems comes from our ability to perceive, synthesize, deconstruct, interconnect, model, and reconstruct ideas, approaches, and solutions using technology. Our education system, for most part, and especially in India, teaches us to be consumers of tech, not creators of tech. I see this a lot when we are hiring our own tech team. We have been getting a few thinkers and doers every year, but most applicants are not like that. It is not about knowing a specific computing language or coding skills. We need lateral thinkers, not scripted followers. So how should we teach technology in college? And fourth, how do we communicate the role of science and technology to retain young talent in the field? I am myself a prime example of someone who drifted away from tech. After an enriching start in the cutting-edge tech of the 1990s, which eventuated in multiple patents, I succumbed to FOMO pretty soon. I was afraid of missing out. I wanted to follow my friends. So I did my MBA and I moved into strategy consulting, a vocation that was perceived more attractive in those days. It's only in the last few years that I have meandered back into leading a tech company and have become deeply immersed in tech problem solving yet again. Shoumik's own journey in quantum information systems is perhaps just as heady, if not more, than the phase I went through with the rise of semiconductors and computers in the beginning and the middle of the 1990s. He clearly has an abundance of options before him today, and as a parent, I remain a curious and invested observer of his dilemmas and his decisions. Some of it is familiar, lots of it is not, because things change, because things get more complex. And I'm fortunate that my husband and I have a ringside view of these dramatic changes, and most importantly, yet another opportunity to learn, to observe, to absorb through his journey. As a tech entrepreneur based in India, some of this learning might help me prepare better for the kinds of disruptive changes we are starting to see here. The pandemic has accelerated the pace of digital transformation, and I, for one, would like to believe that there is opportunity for India and for Indian businesses to leapfrog. When that happens, we must be future ready. To be ready, we must prepare. To be prepared, we need the talent. And that's how we will survive and hopefully thrive. So I'm looking forward to my conversation with Shoumik next week as we discuss the role of frontier science in society and the decisions each one of us has to take as actors in this space. Do join Shoumik and me next week for episode 6 of Talking About My Generation on August 29th at 7:30 p.m. on Facebook. You can register for the event at the link given below. See you next week.